So we are now starting chapter 7. And the title of chapter 7 is Quadratic Equations. And we know what quadratic equations are. Quadratic equations are sometimes also called second degree equations. The degree is the highest exponent. When you have a second degree, it means you have an exponent of 2. You came into this course knowing how to solve linear equations, just regular equations. You probably also knew how to solve quadratic equations, the simple ones, because we've already learned or reviewed how to solve quadratic equations by factoring. In other words, if I gave you an equation that looks like this, you would right away say, oh, this is a quadratic equation. I can tell it's a quadratic equation because it has an x squared in it. And the way we solve this is we get it equal to 0. So we're going to bring the -6 to the other side. And that gives me x squared minus 5x plus 6 equal to 0. And then you factor. And the x squared we break up into x and x. Remember, the positive 6 means both signs are the same. The middle sign is negative, means both of them are going to be negative. And we need numbers that multiply to 6, but add to 5, and that's 2 and 3. So after we factor it, we set each equal to 0. So we do x minus 2 equal to 0, and x minus 3 equal to 0. Here, when we add 2 to both sides, we get x equals 2. And here we get x equal to 3. So we end up with our 2 answers for our quadratic equation being 2 and 3. And we usually do get 2 answers to a quadratic equation. And that's what we have done so far. Some of the factoring was harder, some of them was easier, but basically we relied on this method of factoring. But there is a problem. That's why we are revisiting this topic of quadratic equations, because it's not always possible to factor if you have a trinomial. And sometimes, even if it would be possible to factor, the factoring is so difficult that you can't figure it out. So what do we do in those cases? What do we do when we have an example where it can't be factored? Can we solve the quadratic equation? And that's a question we're going to be trying to answer today. That is what chapter 7 is about. We have this basic method. What happens when the method doesn't work? So in order to do this, I'm going to show you basically 2 different types of methods of solving quadratic equations. One, I'll start out with, it'll be 2 methods in one. But one method will be involving a quadratic formula. You may have heard of the quadratic formula. That's what we're going to do towards the end of the period, which can be used to solve any quadratic equation at all. And it is so important. This is probably the most important topic that we're doing this term, this concept of being able to solve any quadratic equation, any equation that has an x squared in it. We will, by the end of this discussion, which will probably take a little bit into Tuesday as well, we'll be able to solve any kind of quadratic equation. So that's the object. This is chapter 7, and that's what we're doing in chapter 7. So first, I'm going to start with examples that are called incomplete quadratic equations. For example, what if I gave you this equation? X squared equals 9. Well, I know, according to my rule, I'm supposed to get it equal to 0. It's a quadratic equation because it has an x squared. So I set it equal to 0. So I subtract 9 from both sides. And that gives me x squared minus 9 equals 0. And the reason it's called an incomplete quadratic equation is because there's a square term, there's an x squared, but you would normally think that the next thing you'd see would be a regular x, and there's no regular x term, and then you have a number. That's why it's called incomplete. It doesn't matter that it's called incomplete, but there are only 2 terms in it. But again, the method that we used before worked. We factor this. X squared minus 9 is the difference of squares, so I can factor this into x plus 3 and x minus 3. And just like we did before, we set them each equal to 0. So in the first case, x plus 3 equals 0 gives me x equals negative 3. And this one we do, let's just do this, x minus 3 equals 0. So we add 3 to both sides on this side, and we get x equals positive 3. In other words, we get our two answers, negative 3 and 3. Since these are both the same number, sometimes what we write is x equals plus or minus 3. This symbol, where you have a plus over a minus, is just a shorthand way of writing. One answer is positive 3, one answer is negative 3. It just saves me the time of writing the 3 twice. And just even though it was an incomplete quadratic because it didn't have that term, actually the method worked. We got it equal to 0, we factored, we solved. I'm going to show you a method that can be used to solve these incomplete quadratics very quickly. Obviously, if we can do things quicker, then if we can save ourselves time, especially when we get to a test that has 40 questions on it, the ones that we can do the quickest are the ones that will save us time to allow us to use more time on the more difficult ones. So if we have a quick method, let's look at it. So let's go back, and I'm going to show you this new method. It's called the square root method. I'm starting with my exact same equation, x squared equals 9. Now, I'm sure if I had asked you, I have x squared equals to 9, what is x equal to? I'm sure most of you would come up with the answer 3, because 3 times 3 gives me 9. You would be mostly correct. What you would have left out is one of the answers, because negative 3 times negative 3 would also work. In other words, if I'm thinking of a method that I'm using, since this says x squared, if I want to get x, I want to take the square root. The square root. I'm sorry, let me. Hello? So we take the square root of x squared, which gives us just x. Anytime you have something squared, if you take its square root, it just gives you that thing. Square root 100 squared is 100. You just, if something that's squared, you take a square root, it just gives you the x. On the other side that doesn't have the square root, you take the square root of that, so that's a square root of 9. But don't take just the positive answer, you write plus or minus, because when you square the negative, you'll get the same answer as when you square the positive. In other words, the step from going from x squared equaling some number, let's call it n, the next step always goes x equals plus or minus the square root of that number. That's the method that's called the square root of method. Now look at this is, we know what the square root of 9 is, it's 3. So that right away gives us x equals plus or minus 3. I didn't have to do any factoring or anything. This in basically 2 steps did exactly the same thing that we did in 4 steps. Obviously, it's much quicker, gave us the same answer. If it didn't give us the right answer, we wouldn't use it. So when we have these incomplete quadratics, these quadratics that only have the square term and don't have the plain x, we can use the square root method. And I'll show you some examples where it wouldn't be possible to do it by factoring, but it can be done using this method. For example, suppose I have x squared plus 25 equals 0. Again, it's an incomplete quadratic because it doesn't have that x term, but it's not the difference of squares. This is a perfect square, it's x times x. This is a perfect square, 5 times 5, but it's not the difference. It's got a plus, not a minus, which means it can't be factored. But I can use the square root method to solve this. What does the method entail? Get the x squared by itself, so we'll subtract 25 from both sides. That'll give us x squared equals negative 25. And now take the square root of both sides. This is a square root method. Once I have x squared, I can take the square root. The square root of x squared is x. On the other side, it becomes plus or minus the square root of this number, which is negative 25. So just take the square root of this number over here. Now we can actually simplify this. We know the square root of negative 25 is the square root of 25 times the square root of negative 1. And the square root of negative 1 is I. There's our I. That's why we had to learn how to deal with I. In other words, the answer to this question is plus or minus the square root of, plus or minus 5i, because the square root of 25 is 5. So notice, I would never have gotten this kind of an answer. I never get an I when I factor. I never get a radical when I factor, but I can, even if it's not factorable, I can solve it using this square root method. I can even go a step further. What if I have something that looks like this? X plus 3 squared equals 60. Notice I have a binomial squared. Normally, what I would have to do is I would have to multiply the x plus 3 times the x plus 3 to remove the parentheses, combine all the like terms, see I have an x squared, so I'll have to bring everything to one side, and I'll have to factor. I'm going to show you a quick way of doing this. A method that will, again, only entail about 3 steps. Anytime I have something squared, I can use the square root method. The square root of x plus 3 squared is just going to be x plus 3. anytime you have something squared and you take its square root, it just literally removes the exponent too. On the other side, it isn't squared, so I have to actually do the square root. So I have to do plus or minus. Don't forget that plus and minus to get you your two answers. The square root of 6t. And I'm almost finished. I just have to simplify. I know the square root of 16 is 4. So this is giving me x plus 3 equals plus or minus 4. And since what I'm interested in finding is not x plus 3, but x, I'm going to subtract 3 from both sides. Whenever I do this, if I have something on the side with the x and I subtract it or add it, I always want to put it in front. In other words, that'll give me x equals -3 plus or minus 4. And since both -3 and 4 are just regular numbers, I could write this. Remember, this plus or minus is just a shorthand to write one answer being -3 plus 4, and one answer being -3 minus 4. Now, the -3 plus 4 gives me 1. The -3 minus 4 gives me -7. And here are my two answers, 1 and -7. Literally, all it involved is to the solving of it, which was right over here, was 1, 2, 3 steps. This is just simplification. If you had done it the other way, you would have had to use FOIL to remove the parentheses. That would be one step. Then you'd have to collect the like terms. That would be a second step. Then you'd have to bring the 16 to the other side. That would be the third step. Then you'd have to factor, would be 4 steps. And then you'd have to set each of the factors equal to 0. So at least 5 or 6 steps where we're able to do this in basically 3 steps. So the square root method is an extremely efficient way of solving a quadratic equation. Again, you have to have something squared. You have to be either just a plain x squared, or you have to have a binomial squared. But once you have something squared, you could just take the square root of both sides, and that'll give you your solution. I'm going to give you one to try right now. Sheets. Okay. Let me pause the. So we again have something squared equaling a number. So that's this. So the next step is to take the square root of both sides. Now, taking the square root of x minus 3 squared just gives me the x minus 3. Taking the square root of 12, we do plus or minus the square root of 12. Now, when I get a radical, I try to simplify it. The square root of 12 is not a perfect square, but I can break it down into 4 and 3. And the square root of 4 is 2. So this gives me x minus 3 equals plus or minus 2 radical 3 if we're doing this in simplest form. But I still have this 3 on the other side that I have to bring to the other side because I want x alone. So I'm going to add 3 to both sides. And that's going to give me x equals, now remember, what I bring to the other side I always put first. This is a positive 3 because I added 3, plus or minus 2 radical 3. And you know what? I'm going to stop right there because this 3 and this 2 radical 3 are not like terms. This is a regular number. This is a radical. Unlike radicals, they can't be combined. So here's my answer. Notice step 1, step 2, step 3. Literally 3 short steps. Was anybody able to get that answer? Any response? Anybody? Okay, Judy, great, thank you, beautiful. Should we try one more? Should I give you one more to try? Let's say I gave you this one. 4x minus 3 squared equals 4. Let's see if you could do this using the square root method. I'll give you a couple of minutes to try that. See how this is done. We have something squared equaling a number. So the first thing is we take the square root of both sides. The square root of this thing, of the 4x minus 3 squared, is just the 4x minus 3. On the other side, we get plus or minus the square root of the number, which is 4. We're lucky. This number is a perfect square. So this just becomes plus or minus 2. So we get 4x minus 3 equals plus or minus 2. And I have to solve this equation. Well, the first thing I'm going to do is bring the 3 to the other side. That'll give me that 4x equals 3 plus or minus 2. Now, it turns out these are both regular numbers, rational numbers. So I can break this up. If this would have an I or a square root, I wouldn't be able to combine them, and I just leave it like this. But like this, I can combine them. So one answer I'm going to get is 4x equals 3 plus 2. And the other answer I'll get by doing 4x equals 3 minus 2. The plus or minus means once we add it and once we subtract it. So here we have 4x equals 3 plus 2, which is 5. And to figure out what the x is, I divide by 4. So this answer is 5 over 4. This, when I do 3 minus 2, gives me 1. 3 minus 2 is 1. So 4x equals 1. And I divide by 4. So the other answer is 1/4. Here are my two answers, 5/4 and 1/4. And we did it using the square root method. So otherwise we would have had to square this, multiply by itself. That alone takes time. And then after we did that, we then have to go through all the work of factoring and simplifying. This is the square root method. Is there any question before I go on? Maya, you're here. Okay, I'm just looking at my chats before I. Darlenis, I'm pretty sure I marked you. Darlenis, I marked you here. Maya, I'm changing you. I had marked you absent, but you're here. Perfect score so far, Maya. Okay, everybody okay now? So now okay, so this is what's called the square root method, which is all very fine when you have something squared, but most of the time that doesn't happen. So let's go on to the next step. What if I just gave you a regular quadratic equation. Suppose I gave you something like x squared plus 6x minus 15 equals 0. And if you notice, I really can't factor this because this is negative, means one number is going to be positive and one number is going to be negative. And I'll need two numbers that when I multiply them will give me 15. And when I subtract them will give me 6. And I can't think of anything. The numbers are either 1 and 15 or 3 and 5. Neither of them, when you subtract them, give you 6. Here is a perfect example of what can happen when we have a quadratic equation and we can't factor. And I'm going to, and I can't use the square root method as it stands because I don't have anything squared. And I don't have just an incomplete square root because I have the 6x. It's not set up like either of the two types that I just did. It's not set up that I just have a x squared and a number, an incomplete quadratic. And it's not set up like a binomial squared equal a number. So we could use that square root method as well. I'm going to show you something called, I'm going to erase this, which is called completing the square, which makes use of the square root method, but needs a little bit of extra work. Completing the square. And before I get to this problem, I have to do a little bit of preparation with you.
My name is Pete.
Number one, I want you to see what happens when we square a binomial. Let's say I gave you x minus 7 squared. I'm going to do it the long way, and then I'm going to show you there really is a short way of doing this. If I wanted to do x minus 7 squared, I would really have to do x minus 7 times x minus 7. And I'd have to use FOIL. X times x is x squared. Outer is negative 7x. Inner is also negative 7x. And last is negative 7 times negative 7, which is plus 49. And if we combine the like terms, I get as my final answer of squaring x minus 7 squared, x squared minus 14x plus 49. Now I want to show you the pattern, because if you have the pattern, sometimes if you're asked to do something like that and you really know the pattern, and you should, I'm going to explain it to you, it will make it much quicker to do. If I want to do a binomial squared, first thing I do is I square my first term. My first term here is x, so I do x times x, and that gives me the x squared. My last term, I'm going to end up with 3 terms. My last term, or the third term, I get by squaring the last number. This is negative 7. Negative 7 times negative 7 gives me plus 49. But where do I get the middle term from? Well, if you notice, how did I do the middle term? I did the outer and the inner. Notice that gave me the x times the negative 7 twice. The outer gave me negative 7x. The inner also gave me negative 7x. So that I had negative 7x twice, which gave me negative 14x. In other words, the middle term, the term that has the x in it, is simply the product of these two, the x and the negative 7, doubled, multiplied by 2. X times -7 is -7. Double it gives you -14x. Look how quick I could do this then. Suppose I have x minus plus 8 squared. If I want to do this expanding of the binomial quickly, I'm not going to do the whole FOIL. I'm going to remember the pattern. The pattern tells me the first term is the first term squared, x times x, which gives me x squared. The last number is the last number squared, 8 times 8, so that gives me 64. And what is the middle term? Well, I multiply these two together. X times 8 is 8x, positive 8x, and multiply it by 2 because I know I'm doing it twice. 8 times 8 plus 8 is 16, so this becomes plus 16x. Look at how quick it was. I didn't have to do FOIL, I just saw the pattern. What if I gave you x minus 10 squared? Let's do it quickly. First term, x times x is x squared. Last term, -10 times -10 is positive 100. Middle term, x times -10 is -10x, doubled is -20x. Okay, now I'm going to go look at this from a little different point of view. What if I started out with something like x squared minus 10x and blank, and I have two terms, and it's really a trinomial, it's really 3 terms, and I left out the third term. And I want this to be a perfect square. I want this to be a binomial squared. What number would I have to have over here that would make this binomial into a trinomial that's a perfect square? Close, Dominic, not exactly. Let's think. This is why it's called completing the square, because I'm starting with something that's not complete. I only have 2 of the terms. I want to know what the third term is. Well, think about it. How did I get this middle term? I got this middle term by doubling something. I doubled the numbers that I was multiplying. So therefore, what was the number I was doubling? Obviously, I divide this number, -10 by 2, I get -5. That must have been the number in the parentheses with the x. Because the only way this would have been a 10 is if this number was half of it, because I'm just doing the opposite. To get this number, I doubled it. So to get this number, the number in the parentheses, I have to take half of it. And the last number is always that last number in the parentheses squared. So -5 times -5 would have been 25. In other words, for this expression to be a perfect binomial squared, what I need to have is a 25. Again, let's go through, how did I get that 25? I took the number that was in front of the x and divided by 2 and squared it. Half of this squared, half of -10 is -5. -5 squared is positive 25. Now notice I'm always I can only do this when I know my leading coefficient is a 1, that I'm just starting out with a plain x squared. I don't use this completing the square method unless I have that situation. Okay, let's do another one. Suppose I had x squared plus 12x. And I want to know what should I add to these two terms? What's the third term I should have in order to have this binomial to be a perfect square trinomial? So again, let's go through the steps. Take the number in front of the x and divide it by 2. That'll give me plus 6. Then multiply that number by itself. 6 times 6, that gives me plus 36. And what is this in factored form? It's the x plus 6 squared. If you took x plus 6 and you squared it, remember the pattern. X, the first term is x squared. The last term is 6 squared, which is 36. And the middle term are these two multiplied together and doubled. That's 6x times 2 is 12x. So again, to find out what number we should add to make this into a perfect square binomial, let's look at the steps again. Take the number in front of the x, divide it by 2, which means I'm only going to do this if this number here is easily divided by 2. In other words, it's even. And multiply that by itself. Half of 12 is 6. 6 times 6 is 36. Okay, I'm going to show you how that will help us solve this example that I have over here, the x squared plus 6x minus 15. I'm going to go through the steps of solving this using what's called the completing the square method. Step 1 in completing the square method is, as opposed to any other method that's solving quadratic equations where you want to get it equal to 0, here you want to have just the x's on one side and any number, any plain number on the other side. So the first thing I'm going to do is I'm going to add 15 to both sides so that I end up with x squared plus 6x equals 15. Now, if you notice, even though I added 15, I didn't get rid of the space. The space is very important because I'm going to fill it in. I'm going to fill in the space. What I'm going to do is I'm going to complete the square on the side. Now, I only want to use this completing the square method if I have a leading coefficient of 1, which I do, it's just a plain x squared, and if the number in front of the x is even, which it is. Now, remember what we do with the completing the square. We take half of the number that's in front of the x, so half of 6 is 3, and multiply it by itself. 3 times 3 gives me 9. I have to add 9 in order to make x squared plus 6x plus 9. That is a perfect square trinomial. That's a perfect square. And it's what it is the x plus 3 squared. Now, be very careful. I added 9 on this side of the equation. I better add 9 to the other side as well. I cannot add something to one side of the equation without doing the exact same thing to the other side of the equation. Now, I force this side to be a binomial squared. On the other side, what do I have? I have 15 plus 9, which is 24. And if you notice, it now looks exactly like those examples I was doing using the square root method. I have forced the regular trinomial quadratic into a situation where I can use the square root method because I have something squared equaling a number. Now remember what the square root method tells me. Take the square root of both sides. The square root of the x plus 3 squared is just the x plus 3. On the other side, it's a plain number, so I have to do plus or minus the square root of 24. Now, the square root of 24 is not a perfect square, is an irrational number, but I can simplify it to the square root of 4 and the square root of 6. And the square root of 4 is 2. So this becomes x plus 3 equals plus or minus 2 radical 6. And now just bring the 3 to the other side. And that gives me x equals, remember the number I bring from the other side always goes first, so that's negative 3 plus or minus 2 radical 6. Notice these are not like terms, so this is my answer. Look at this. I had a quadratic equation that was not factorable, but yet I could solve it using this, completing the square method. Okay, let's try another one. Okay? Now that we have all the steps together, let's try another one. I'm going to do one more and then I'm going to give you one to try. A squared plus 10a plus 22 equals 0. See it? Let's work on this together and then I'm going to give you one to try. If you think about it, I see that I cannot factor it. Why? Because I can't think of any numbers that multiply to 22, but when I add them, will give me 10. The only numbers that multiply to 22 are 2 and 11, and they add up to 13. They don't add up to 10. In other words, this is not factorable. Notice this method can be used even if it is factorable, but in this case, it's not factorable. And it's set up well for completing the square because the leading coefficient is 1. There's just a plain a squared. And the plain a term, not the a squared, but the a term, has an even coefficient. It has a number in front of it that's even. So if I recall the method, the first thing is to do is just isolate the variables, get any plain number to the other side. I'm going to bring the 22 to the other side, which will give me a squared plus 10a equals negative 22. Now remember, you always want to leave a space because we're going to be completing the square. We're going to be adding something to make this binomial into a perfect square trinomial. And what we do is we take the number that's in front of the a or the x term, which is the 10, divided by 2, so that gives me 5, and multiply that number by itself. 5 times 5 is 25. 25 is the number that I have to add to make that into a perfect square binomial. Of course, when I add 25 to one side, I've got to add the 25 to the other side as well. And let's see what we're left with. Over here, I can write this in its factored form as a plus 5 squared. The whole point was to make it into a binomial square. On the other side, I have negative 22 plus 25, which is just plain 3. And now I use the square root method. I take the square root of both sides. On this side, I just get a plus 5. On the other side, I get plus or minus the square root of 3. And now I've got to bring this 5. I want to know what the a alone, so I'll subtract 5 from both sides. And that will give me a equals -5 plus or minus radical 3. And these are not like terms, they're not like radicals, they can't be added. So this is my final answer. Okay, are you ready to do one on your own? Let's see if I can give you one on your own. Don't forget to look on Delta Math to make sure you're doing all the exercises. I'll post exercises on this by the weekend for sure. Okay. Suppose I give you this, x squared minus 4x equals -5. I'm going to give you a few minutes to try and solve that on your own. Stand it while I do it. Okay, let's see let's see how we're going to do this. Oh, this is supposed to be x squared. That's probably the problem here. I didn't write x squared, I just wrote x. Did everybody realize that this was supposed to be an x squared? Yeah, then it would have been just -3x. You're right. Okay, I'm sorry. Let's do this. Obviously, now I'm going to do this using completing this square. Otherwise, it only works if it's a quadratic. And if I didn't have an x squared, then it wasn't a quadratic. But let's remember the steps of completing the square. I know that what I'm supposed to do is I'm supposed to, first of all, I want to have only the x terms on one side and the regular number on the other side, which is set up perfectly for that. And what I want to do is make this into, I want to add something to make this into a perfect square binomial. And I do that by dividing the number in front of the x by 2. So that gives me -2. And -2 times -2 is +4. The number I have to add to make this into a perfect square binomial is 4. Of course, if I add 4 to one side, I have to add 4 to the other side. And in factored form, this is x minus 2 squared. And on the other side, I have -5 plus 4, which is -1. And now I go to my square root method. The square root of x minus 2 squared is just x minus 2. And on the other side, we do plus or minus the square root of -1. Oh, the square root of -1, I know what that is. That's I. So that means that x minus 2 equals plus or minus I. I add 2 to both sides to get the x alone. So that gives me x equals, remember I always put the number that I'm adding in front. So there's my 2 plus or minus my I. I can't combine the 2 and the I, they're not like terms. So here's my final answer, 2 plus or minus I. So that's what's called completing the square. We'll do more of these. You'll have some more for homework, and I'll do some more of these on Tuesday. But I want to show you one other method. And the method I'm going to show you now, which is called the formula method, is probably the most important one because it has no restrictions. It can be used on any quadratic equation. Remember, we only want to use this method when we start out with a leading coefficient of 1 and my number in front of the x is even. Now that's not always the case. Sometimes we have other numbers in front of the x squared. Sometimes we have odd numbers, sometimes we have fractions. The completing the square method could be done in those cases, but it becomes so complex with such complex fractions that it becomes almost impossible. So that's why when we want to do the completing the square method, we really only want to do it when we have a leading coefficient of 1 and an even coefficient in front of the plane x. So now let's look at this other method, this formula method. First of all, I'm going to write it out. I'm going to write out what the formula is. A formula is just a method. If you have a formula, all you have to do is stick in the numbers and it gives you the answer. And that's exactly what this formula does. And probably the most important formula that you'll learn this term, and the most important thing that you'll learn in this course, is solving quadratic equations. The quadratic formula looks like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is called I'm sure some of you have seen this before. I don't know if you've all seen it, but this is what's called the quadratic formula. And there are 3 letters in this formula. There's an A, a B, and a C. And if you know what the A, the B, and the C are, then you just stick them into the formula and it gives you the answer to the question. Now, where do I get this A, B, and C? So, first of all, any quadratic equation is of the format ax squared plus bx plus c equals 0. Whenever we have a quadratic equation, which we recognize because it has an x squared, we want to get that equation equal to 0. That's what's called the standard format. The only time we don't have it is when we want to use completing the square, but we're using the formula method, and that requires us to have it equal to 0. Then the number in front of the x squared is what's called the a. The number in front of the plane x is the b. And the c is the number that stands alone. It's the constant. It doesn't have any x next to it. Be very careful. Some of these numbers might be negative. If the numbers are negative, then the negative is part of the answer. In other words, if this says -7, your C is not 7, your C is -7. The sign is part of the number. So let's say I have something like this. X squared plus 8x equals 5. Now, first of all, if I want to use the formula, and remember, I really probably could use the completing the square method on this one because it starts with a leading coefficient of 1 and the number in front of the x is even. But the quadratic formula method works for any kind of quadratic equation. As a matter of fact, I usually, if I have to solve a quadratic equation and I just easily factor it, well, this is the method I usually use. I don't go to the completing the square method, because I know this method for sure will work. So what do I have to do? The first thing I have to do is get it equal to 0. So I'm going to subtract 5 from both sides so that I get x squared plus 8x minus 5 equaling to 0. And I write down what my A, what my B, and what my C is. Now, in order to make this clearer, I hope it'll help it clearer, I'm going to call my A is going to be the red number. The A is the number in front of the x squared. There's no number in front of the x squared, so I'm going to call that 1. Anytime you have a no coefficient, it's understood that the coefficient is actually 1. My b is going to be blue. What is my b in this equation? That's the number that's in front of the x. In this case, it's a positive 8. So my b is 8. And my c, I'm going to use green for. What is my c in this case? My c is the standalone number, the number that doesn't have any x next to it, which is -5. It's a -5 because the c, it always says plus c, and this is plus a -5. The negative is always part of it. And now I'm going to take these three numbers and I'm going to stick them into this formula, because that's what a formula is. It's just a method of finding an answer. So if I stick it into the formula, I'm going to do -b. So it's going to be negative. Here's my b. My b, I'm going to replace with 8. Plus or minus. Here's my square root. B squared. So here's my b squared. In place of the b, I'm putting an 8. Notice I'm using parentheses in place of the letters. -4. Okay, the next letter I have to put in is the A. The A is red, A is 1. And the C is the last number that goes in there. And the C we said is -5. And this is all over 2A. And again, my A is my red. Notice all I've done, I wrote out what my A, my B, and my C are by looking at it once it was in standard form. And then I just substituted those numbers into the formula. Now it's a matter of just figuring out the numbers. Just be careful, especially with your signs. Okay, this is a -8, so that's -8. Plus or minus, we know what that means. It means one answer is going to be the add and one answer is going to subtract. The square root, okay, let's see what we're going to get in here. It's 8 squared, so that's 64. -4 times 1 times -5. Now we're multiplying three numbers. A -4 times a +1 times a -5, which gives me a +20. Here's where you have to be very careful because you want to make sure your numbers are, you're being careful with your signs and your numbers. Okay, and it's all over 2 times 1, which is 2. So this ends up being -8 plus or minus the square root of 84 divided by 2. And this is our answer, but it's not simplified. This is all the work that we need to do to get the answer. The only thing that's left to do is to simplify the radical. So let's see what we can do with the 84. The square root of 84, let's see, what numbers? I think we could divide it by 4. Is the square root of 4 times the square root of 21. Remember, 84, we want to find one of the numbers being a perfect square, and 4 is. So this becomes 2 radical 21. So my answer becomes -8 plus or minus 2 radical 21 over 2. Now, these two numbers can't be added because they're not like radicals. This is an 8, a plain number. This has a radical 21. But the top is actually a binomial, and the denominator is just a 2, which is a monomial. We can divide, if I could find something that goes into all three of those terms, in other words, the two terms on the top and the one term on the bottom, we can divide it. And every single one of those numbers can be divided by 2. 2 into -8 gives me -4. 2 into 2, remember when you're dividing something into a radical, you're just using the number outside divided into the number outside. 2 into 2 is just 1, so this has become plus or minus 21. And that's all over 1. Now I don't have to write that 1 on the bottom. My final answer then becomes -4 plus or minus radical 21. Probably the hardest part of this is being careful to simplify properly. Remember, if there's, as long as there's a number that goes into all three terms, the -8, the 2 radical 21, and the 2, which was a 2, we could cancel it out. Okay, so this is where we're going to start on Tuesday. We're going to do several more of these questions. I want you to memorize the formula for Tuesday. It is so important that you know this formula. You should, at this point, even if you can't do the complete example, you should be able to put a quadratic equation into its standard format and know which number is the A, which number is the B, and which number is the C, so that you can stick the numbers into the formula. Does anybody have any questions that they want to ask me? Let me see, there's a couple of questions on the chat. Let me see. Okay, no, I answered those questions already. So we're going to stop again. Let's remember, we're going to be having a test on Delta Math next week. I'll announce it on Tuesday as to what the dates are. I'll give you a few days over which to do it. It will be on chapters 5 and 6. What we're doing now is chapter 7. We're basically going to be finishing chapter 7 and starting new material on Tuesday. Okay, everybody have a nice weekend.